Hi everyone, welcome back to Power Electronics session 9. I hope you got all the topics from the commutation circuits. Now we will discuss about some of the gate exam questions from commutations. This question is given in one of the gate exam like this. Thyristor T in the figure is initially off, that means this is initially off, and is triggered with a single pulse width of 10 microseconds. That means this is triggering with the help of gate pulse. That's the meaning. No need to worry about the pulse width. It is given that inductance value 10 by 5 microhenry, capacitance value 10 by 5 microfarad. Assuming latching current and holding currents of the thyristor both are 0. That means latching and holding current are both are 0. Initial charge on the capacitor is 0, no charge on the capacitor. T conducts for, that means once this thyristor is turned on with the help of gate pulse, how long this thyristor will be in conduction. If you look at this circuit diagram, and you can assume, you can get that this is actually class A commutation circuit. That is nothing but load commutation or self commutation. And here the load is given LC, that means it is an ideal source, ideal load. It is not non-ideal. That means resistance is not there yet, means this is nothing but it is the, what type of circuit it is? We discussed based on the resistance, nothing but based on the damping. So this is undamped system. In case of undamped system, we discussed that like the thyristor will be in conduction once it is turned on, that is given by T equal to pi by omega naught. That means that time, like pi by omega naught time, this thyristor will be in conduction. After that, this current will come back to 0 and then this thyristor will be turned on. That is given by pi into root LC. Now substitute all the values which are given in the question. So pi into root LC, root of L is 100 by pi into 10 to the power of minus 6, and capacitance is also 100 by pi into 10 to the power of minus 6. If you look at here, 10 to the power of minus 6, 10 to the power of minus 6, 10 to the power of minus 12. 100 by pi, 100 by pi square, but under root. That's why if you apply the root and square, then it will be pi into 100 by pi into 10 to the power of minus 6, because it's 10 to the power of minus 6 whole square under root. So then this thyristor will be in conduction after turning on for 100 microseconds. So that is answer. Move on to the next question. So next question is given like this. A voltage commutator chopper circuit operated at 500 H is shown in figure. If the maximum value of the load current is 10 ampere, then the maximum current through the main thyristor M and auxiliary thyristor A will be. So this is the main thyristor M, this is the auxiliary thyristor A. So no need to worry about that what type of circuit it is. This is a kind of like a chopper circuit, nothing but DC to DC converter, but main concentration is on the commutation circuit. So that is what is like our intention, to calculate commutation things. Now look at here, what type of commutation circuit? It is given already, voltage commutated, but if you want to know that, you can also look at the circuit diagram. When you start the commutation of this thyristor, if the capacitor alone connected across the thyristor, then it is a voltage commutated circuit. When you start the commutation for this main thyristor, LC circuit is connected across the thyristor, then it is called as a current commutation. But now look at here, auxiliary thyristor is turned on, then current, like a capacitor will be connected across the thyristor. That means this is a voltage commutation circuit. In case of voltage commutation circuit, we discussed like a maximum value of currents in each thyristor. That means current flowing through the main thyristor maximum value. So that is equal to I naught plus IC max. Okay, and how to calculate the IC max? IC max is nothing but initial voltage across the capacitor, that is nothing but source voltage 200 in this case into root of C by L. C is 0.1 microfarad from the question set. This is 1, and L is 1 millihenry, that is nothing but 1 into 10 to the power of minus 3. So here this 10 to the power of minus 3 gets cancelled here, minus 3 times, that means here 10 to the power of minus 3 will be remain into 0.1, that means 10 to the power of minus 4, under root will be 10 to the power of minus 2, that means 200 into 10 to the power of minus 2. So that is nothing but 2 ampere. So maximum current flowing through the main thyristor will be sum of these two, nothing but load current and capacitor maximum current. So load current is given 10 plus 2, that means 12 ampere. Likewise, auxiliary thyristor maximum current. Auxiliary thyristor maximum current, as we discussed, it is only load current, then it is 10 ampere. So these are the answers for the given question. Okay, now next question is like this. The circuit in the figure is a commutated current commutated DC to DC chopper. Look at that. This is DC chopper circuit, that's not important, but we are mainly considering commutated. Look at here. The moment if you turn on this means LC circuit is connected across the main thyristor. That means this is a current commutation circuit. It's already given, but again I'm telling that. So where THM is the main SCR and TH-aux is the auxiliary thyristor. The load current is constant in 10 ampere. THM is on and auxiliary thyristor is triggered at T equal to 0. THM is torn off between. That means here it is given that both the thyristors are turned on together. That means this thyristor is triggered at T equal to 0 and this thyristor is also triggered at T equal to 0. Both the thyristors are triggered at T equal to 0. Then how long this thyristor, main thyristor, will be in conduction? That's what if you find out. Then obviously you can able to answer the given question. Okay, that means indirectly it is asked like where this thyristor is turned off. That is 0 to 25 millisecond, 25 to 50 and so on like that. That means indirectly it is asked about how long this main thyristor will be in conduction. So we discussed already how to calculate this. I already given the equation related to this in the last session. So that is nothing but if both the thyristors are turned on together in current commutation circuit, then main thyristor will be in conduction for T equal to 5 plus sine inverse of I naught divided by IC max into whole multiplied with LC. So this is what we discussed. Now we need to substitute everything. So before that, first we need to calculate the IC max. What is IC max? IC max is initial voltage across the capacitor, that's nothing but source voltage. So source voltage 230 into root of C by L. C is nothing but it is a 10 microfarad, 10 into 10 to the power of minus 6 divided by L is given 25.28 into 10 to the power of minus 6 because it is also micro. So that gives If you calculate the things properly, then it will be 144.66 ampere. Now substitute here, get the things. That means T equal to pi plus sine inverse of 10 divided by 144.66 into LC, root of LC. Root of LC means, as we discussed, 10 into 10 to the power of minus 6 into 25.28 into 10 to the power of minus 6. Okay, so now if you calculate again these things, T equal to pi plus, the sine inverse will give you, by using your calculator, it is around 3 point something degrees. But as I told you that when you calculate time outside the trigonometric functions, we need to use the radians. If you convert this into radians, then it will give 0.0691 radians into root x. So 10 into 10 to the power of minus 6 into 25.28 into 10 to the power of minus 6. Then if you recalculate, then again it will give you 51.05 microsecond. That means this main thyristor is turning off at 51.05 microsecond once you turn on both the thyristors at equal to 0. That means this thyristor, main thyristor, will be turned off between 50 micro and 75 microseconds. That means it is turning off between 50 and 75 microseconds. So that's the meaning of this. Okay, then move on to the next question. A voltage commutator circuit is shown in figure. That means class C commutation is given. This is also voltage commutation circuit, because when you turn on other thyristor, when one thyristor is in conduction, this charged capacitor will be applied across the conducting thyristor and it reverse biases. That's why it is voltage commutation circuit. If the turn-off time of the SCRC is 50 microsecond and a safety margin of 2 is considered, what will be the approximate minimum value of capacitor required for proper commutation? That means here we need to find out what will be the capacitance we need to have here to get the proper commutation. We discussed one equation related to this one. So what is that? Circuit turn-off time of the thyristors. Both the resistors are same, that's why we can take that circuit turn-off time of the thyristors in this case is RC log 2 base E. But here resistance is already given 50 ohm, and log 2 we can calculate. Circuit turn-off time is given in the question, then you can calculate the capacitance value. But here one catch is there here. So circuit turn-off time is different and the turn-off time of the thyristors are different. Both are different. Both are not same. Okay, remember. Circuit turn-off time is, it is the time in which thyristor is reverse biased by the commutation circuit. Turn-off time of the thyristor is, it is the time taken by the thyristor to stop the conduction once the thyristor is, once the commutation is started. That means how long the thyristor will take time to reduce the current to 0 when you start the commutation. That's it, turn-off time. Okay, so generally the relationship between the circuit turn-off time and turn-off time is like that. Circuit turn-off time generally represented with TC is nothing but turn-off time generally represented TQ multiplied with factor of safety. Okay, so that's what we need to remember. Remember, another important thing is circuit turn-off time of any thyristor must be more than turn-off time of the thyristor for proper commutation. assume circuit turnout time is lesser than the turnout time of the thyristor, then obviously you can't turn off the thyristor at all. So that's what we need to remember. Okay, circuit turnout time must be more than turnout time of the thyristor. That's very important. Now substitute everything and then get the capacitance value. C equal to circuit turnout time TC we need to. TC is nothing but like turnout time is given 50 microsecond multiplied with factor of safety 2 whole divided by R is given 50 into log 2 DC. Okay, then C is will be approximately it is 28.28 microfarad. So that is the answer for this question. Okay, with this I am stopping the video. Okay, for the commutation circuits, I can say we completed the commutation circuits. This is required for the next lessons like inverters and DC to DC converters. Okay, we'll discuss inverters in the next session. Thank you.